The asteroid belt between Mars and Jupiter is a fascinating place. It's home to thousands of asteroids, some of which are as large as planets. Moreover, while it seems like a dangerous place to be, the reality is that it is safe. Most people know that there is an asteroid belt between Mars and Jupiter. However, what they need to realize is just how big it is. In this video, we will explore the real scale of the asteroid belt and what it means for our solar system. From the size of the asteroids to the distance between them, stay till the end to learn more about this fascinating part of our universe. Asteroids known as minor planets are rocky, airless objects left over from the early ages of solar system's creation roughly 4.6 billion years ago. The central asteroid belt, which extends between Mars and Jupiter, is home to the most of this old space debris. Asteroids range in size from the largest, VESTA, which has a diameter of roughly 329 miles, 530 kilometers, to bodies about 33 feet, 10 meters wide. Today's video will cover the real asteroid belt scale between Mars and Jupiter. Before we proceed, click the like button and subscribe to this channel for more content. Click the bell icon to sign up for new video alerts. Have you completed this already? Let us start. The solar system's asteroid belt is a torus-shaped region roughly halfway between Jupiter and Mars orbits. It has many asteroids or minor planets, solid bodies with varying shapes and sizes smaller than planets. To distinguish it from other asteroid populations in the solar system, like Trojan asteroids and near-Earth asteroids, this asteroid belt is sometimes known as the Significant Asteroid Belt or Central Belt. The asteroid belt is the solar system's tiniest and innermost circumstellar disk. The four largest asteroids, Ceres, VESTA, Pallas, and Hygiea, account for about 60% of their mass. According to calculations, the asteroid belt's overall mass is equivalent to 3% of the Moon. VESTA, Pallas, and Hygiea all have mean diameters of less than 600 kilometers, making Ceres the only object in the asteroid belt large enough to qualify as a dwarf planet. Ceres has a diameter of roughly 950 kilometers. Since the asteroid's material is so sparsely distributed, many uncrewed spacecraft have passed through it safely. Large asteroids do not occasionally collide, and this might result in the formation of an asteroid family whose members share similar orbital properties and chemical compositions. Individual asteroids in the belt are divided into three major classes based on their spectra: metal-rich, M-type, silicate, S-type, and carbonaceous, C-type. The asteroid belt originated as a collection of planetesimals from the first solar nebula. The tiny progenitors to the protoplanets are called planetesimals. However, gravitational alterations from Jupiter gave the protoplanets between Mars and Jupiter too much orbital energy for them to accrete into planets. Planetesimals and most protoplanets broke apart due to very violent collisions that prevented them from merging. As a result, during the first 100 million years of the solar system's existence, 99.9% of the asteroid belt's original mass was lost. Eventually, some pieces made it into the inner solar system, where they struck the inner planets with meteorites. Every time an asteroid's period of revolution about the Sun finds an orbital resonance with Jupiter, asteroid orbits continue to be noticeably disrupted. A Kirkwood gap develops as they are swept into other orbits at these orbital lengths. The near-Earth objects, the centaurs, the Kuiper belt objects, the dispersed disk objects, the sednoids, and the Oort cloud objects are classes of minor solar system bodies in distant areas. On Ceres, the most prominent object in the asteroid belt, water vapor was discovered for the first time with certainty on January 22, 2014, according to the European Space Agency, ESA scientists. The Herschel Space Observatory's far-infrared capabilities were used to make the detection. Since comets, not asteroids, are commonly thought to sprout jets and plumes, the discovery was unexpected. According to one of the scientists, the distinction between comets and asteroids is becoming increasingly hazy. Discovery of the asteroid belt. German astronomer Johann TITIUS noticed a mathematical pattern in the arrangement of the planets in the 18th century, and he used it to predict the existence of one between Mars and Jupiter. Astronomers searched the heavens for this missing body. The Celestial Police, a group of 25 astronomers, began looking for the missing planet in 1800. Each member of the group looked at 15 degrees of the zodiac. However, Italian astronomer Giuseppe Piazzi, who is not a member, made the initial discovery in this area and gave it the name Ceres. Pallas's body was discovered a little over a year later. Both of these things were once thought to be planets. However, as more of these artifacts were discovered, more than 100 had been located by the start of the 19th century. These were soon renamed asteroids by scientists, who determined that they were too tiny to be called planets. Asteroids can be divided into 3 general composition classes: C, S, and M types. The most frequent asteroids are of the C type, chondrite. They are black and most likely made of silicate and clay rocks. They are some of the solar system's oldest objects. The M types are metallic, and the S types are composed of silicates and nickel iron. The compositional variations of the asteroids are correlated with their formation distance from the Sun. After some developed and partially melted at high temperatures, iron sank to the center and pushed ballistic volcanic lava to the surface. The strong gravitational pull of Jupiter and occasionally close runs with Mars or other objects have the power to alter asteroids' orbits. These collisions can eject asteroids from the central belt and launch them across the orbits of the other planets. The geological history of the planets and the development of life on Earth have been significantly impacted by stray asteroids and asteroid pieces that have collided with Earth and other planets in the past. Earth-crossing asteroids whose tracks cross Earth's orbit and near-Earth asteroids, which come within about 28 million miles, 45 million kilometers, of Earth's orbital distance and may be dangerous if they collide with it, are constantly monitored by scientists. Radar is an effective instrument for spotting and eyeing potential collision dangers. Images and other information can be gleaned from the echoes of sent signals reflected off objects. An asteroid's orbit, spin, size, form, and metal content can all be discovered by scientists. The asteroid belt is often thought of as a vast space. It's a crowded region with hundreds of thousands of asteroids orbiting the Sun. The vast majority of these asteroids are tiny, but there are also many larger asteroids. About 2 to 4 times the distance between the Earth and the Sun, or between Mars and Jupiter, is where the main belt, about 140 million miles broad, is located. The 8 subgroups of the belt's objects are called after the largest asteroids in each group. The Hungarians, Floras, Phocaea, Coronis, Eos, Themis, Cybelus, and Hildas are the names of these tribes. The journey is uneventful despite the frequent depictions of ships making close misses through the asteroid belts in Hollywood. Several spacecraft, including NASA's New Horizons mission to Pluto, has safely passed through the asteroid belt. Fortunately, the asteroid belt is so vast that despite the abundance of small rocks, the likelihood of colliding with one is far less than 1 in a billion, according to Alan Stern, the principal investigator for the New Horizons spacecraft. You must aim for an asteroid if you wish to get close enough to conduct in-depth examinations of it. The solar system's asteroid belt is significant for several reasons. It is believed to be the origin of most meteorites that hit the planet. Asteroids could be a source of resources for upcoming space exploration because they are abundant in minerals and metals. Research into asteroids can help us understand how our solar system formed and developed. It's incredible to think about the size of the asteroid belt between Mars and Jupiter. Although it might not seem like much when we look at pictures of it, the scale is quite large. The largest asteroids in the belt are hundreds of miles wide, and there are millions of smaller ones. The vastness of the solar system makes it incredible that there is so much matter in a tiny space. It makes you truly aware of how ample and empty space is. The video for today is over. If you want to see more, remember to thumbs up this video and subscribe to the channel. Remember to click the bell symbol to receive notifications when new videos are posted.